Alrighty, y'all, welcome. This is going to be a virtual lab of types of reactions. So follow along with the sheet that's going to be posted along with this video and take the observations, and then from that you should be able to fill in all the blanks, do the balance of the equations, and be able to tell me the types of reactions. So looking at your reaction sheet, at the first type of reaction is going to be a reaction of magnesium. We're going to take some magnesium metal and we're going to just take it here in the hood, and remember that the hottest part of the flame is that interior blue cone, so we're just going to put it into here, and you can see that it's burning a very bright white, giving off a lot of heat. Okay, and then we tap it and we can see that we have a white ash formed as a result of that combustion reaction. Okay. Now, when we come over here to the second one, is that they want to take some sulfuric acid. Now, when you are doing a reaction in a test tube, you never want to hold the test tube in your hand. You always want to make sure that you use a test tube clamp, or you just do it in the rack. So we're going to take some sulfuric acid, okay, and we're going to fill a test tube. This is a totally qualitative lab, so we're just going to take some. We're going to put it into here, and the squirt bottle needs the tip needs to be cleaned. Okay. And I'm just going to speed the whole thing up here. I'm just going to put a little bit more in this way. So now I have a test tube with about a fourth or a third with H2SO4. Then it says to take a small piece of magnesium, okay? And I want to have a wooden splint ready to go and burning. So I have this wooden splint. Now I'm going to just drop this into, and we immediately see that it's bubbling and fizzing. And when I put the wooden splint over the mouth, I don't know if you could see that, but there was a fire that came up out of the mouth of this. Okay, let's see if we can get it to go again. Okay, oh, there was a little bit of a pop right there. So you can see that it's indeed bubbling, and there's a gas being given off, and the gas that's being given off is flammable. And then when I feel the bottom of this test tube down here, I only hit the flame up here. When I feel the bottom right where the reaction is, it's very hot. Okay, so you need to record that in your observations, that it's very, very hot as the reaction is taking place. So also note that the magnesium is completely disappeared, okay, from the solution. Okay, so that was the reaction 2. The third reaction is, let me get my sheet, my third reaction. I thought I could have it memorized. The third reaction is we want to use copper sulfate. Okay. Notice the deep blue color of the copper sulfate. Now again, this is a solution. It's an aqueous solution. This is not pure copper sulfate. Is a solid. Ionic compounds are solid at room temperature. So the only way to get them to react is to dissolve them into water. And we're supposed to put some iron. So here's some iron filings you can see. Okay, it's filings, not fillings. We're just going to take a scoop of this. Okay, and again, we're never going to hold the test tube in our hand. We're always going to hold it with a test tube rack. And I'm going to put this scoop into here. Okay. Now immediately you can kind of see underneath that the iron filings, it kind of forms this reddish brown. Now I'm going to take this. I can tell that it's not going to bubble over or anything, and I'm just going to try to mix it up really well. Okay. And you can really see the reddish brown solid forming at the bottom, and the blue color is actually slowly fading away. Okay, so you're getting a reddish brown solid there, and then the blue color is fading away in this reaction. Okay? So you need to just kind of, again, kind of record all those observations down and just kind of see, you know, what's happening and write your balanced equation for, again, you had your copper sulfate aqueous solution combined with iron filings, that's just Fe, and you end up getting this, and we'll come back and look at this one after we let this settle out just a little bit. So then we go to the fourth reaction, which is we want to take another test tube and we want to put some HCl into it. Okay, so I'm just going to save some time and pour some HCl. Let a little bit of water out of there. Some HCl. And then I'm going to use this stuff called phenolphthalein. Now phenolphthalein is what we call an indicator. It changes color but when it's in an acid or a base. And in an acid, I'm just going to use 2 or 3 drops. Well, 2 or 3 or none drops. Ooh, okay. Note to self, we need to fix that bottle. So we go over here and get another bottle. Same stuff. Try again. 1, 2, 3 drops. Okay? And notice there's no real color change. Now I'm going to take some NaOH. Some NaOH. Okay? It's the same strength, so I'm going to go and I'm going to pour a whole bunch in. Okay? Now where the H pluses from the acid are seeking out the OH minuses from the base, and where there's a bunch of OH minus, it turns that magenta color. But now there's more H pluses than there are OH minuses, so I'm going to add a little bit more. Okay? So now, will it stay or will it go? So the color stays now, and as a result, we now have more OH minus than we do H pluses. So when there's more OH minuses, the phenolphthalein is this magenta color. Now we can go backwards and add some more HCl, and see if they can seek out the OH minuses. Oh, crud. None of these squirt bottles want to work very well. We got to fix all those. I can add some HCl, and if I add just enough, I can make the magenta color go back away, and that tells me now I have more H plus. So if there's more OH minuses present, then I have magenta color. If there's more H pluses present, then I end up having a colorless. So just to kind of play around and have fun, I could put just a little bit more. Drop-wise, ooh, and I'm getting magenta everywhere. And now I'm 1 drop. So the reality is I'm very, very, very close to that neutral point, okay, to where H pluses and OH minuses equal one another. All right, so I'm gonna wash my hands and try and get some of this stuff off. Always a good safety thing. We have to work on our squirt bottles. All right, so the next reaction, reaction 5, is the reaction, and we're going to take some manganese dioxide, but the actual proper name of this is manganese 4 oxide, because really you don't use prefixes with the ionic compounds. But we're just going to take some of this, and this manganese dioxide is going to be used as a catalyst for the reaction, okay? If you recall, a catalyst speeds up a reaction. It's not a reactant or a product. So think about, where does the catalyst MnO2, where would you put that in your equation? And we can even look at this bottle, and if you look at this bottle, you can see that there's little tiny bubbles on the inside of this bottle already just sitting out, because hydrogen peroxide decomposes all on its own. Now again, we never ever hold a test tube in our hand, okay? And we want to have another splint on fire, ready to go here. So I have the splint on fire, And I'm just going to take some peroxide and pour it into the test tube. And immediately you can see it bubbling in here. So I'm gonna tap this out, and I'm gonna put this down in here, and it's magic. It's kind of like those magic candles, the birthday candles, that they just won't go out. You just keep putting it back in there, and it catches back on fire, okay? So we have to figure out, well, what is it being given off in here that causes this to be catching on fire? So it's just kind of bubbling still down here, okay? And it's getting very warm again down at the bottom. So that is our fifth reaction. That's the hydrogen peroxide being added to the MnO2. But the MnO2 is actually going to be a catalyst, not a reactant. And then lastly, we're going to take some sodium bicarbonate. And we're going to put some sodium bicarbonate into a test tube. Okay? Again, we never want to hold the test tube in our hand. And we're going to take some more HCl. I just put the lid onto it and I didn't need to. Okay? Oop, that's NaOH. We want to always read your label first. Okay? And when I go and I put the HCl in, this is the squirt bottle that doesn't work. Let's try this squirt bottle. Okay? When we put this in, again, you can see bubbles being formed immediately. Okay, it's bubbling up big time. And then when I go and I feel the bottom of this test tube, it actually feels cool. It's not hot. This one's actually getting a little bit cold. So we can see bubbles are being given off, and it's getting cold on the reaction. So those are our 6 types of reactions. Now I'm going to come back. I told you we'd come back and look. Okay, so now you can really see, this is that copper sulfate plus iron. You can really see the copper, the precipitate forming at the bottom, okay? And then the color, notice the color has faded dramatically because the blue color is due to the presence of dissolved copper. So we need to write a balanced equation for this. So this again was that third equation where we put the iron in with the copper sulfate. All right, so those are all the different reactions for this types of reactions lab. So you can go through and you can look at those. You can fill in the observations. You can fill in and write your balanced equations. And you should be able to answer all of the questions now based upon what we just did in this reaction. All right, now if you have any questions, feel free to either email or ask your teacher. And we'll be glad to answer any questions that you have regarding this lab.